So now we're going to do our multiply chart. You will find directions for this in the Pebble Maths teaching manual, but I will try and make it very clear here for those for whom reading is not the best way. So we need to, I like the children to actually draw their own squares, but if your child doesn't have the patience, or for me who can't be bothered, this is the template and I print them out. So I need 7 of these because these are 17 across, 12 down. They have to be perfect squares, please. And I need 7 because we're going to go all the way to 100. Now, I have a completed chart, but I'll go through the construction of the chart as we go. So this is the completed chart, where on the top row we go from 1 to 100. Now you'll notice everything's in red and blue. Red numbers are our odd numbers, blue numbers are our even numbers. Very, very, very important. So you need to stick your papers together and make like this, a scroll, and this can be rolled up. The children can take them to school, or you can stick it on the wall where your child does his or her homework. So we have 12 numbers down and 100 across. So we've done our numbers from 1 to 100 along the top. That's what we do first. And so the children are changing, and I like them to call the numbers as they go. So odd 1, red, even 2, blue, odd 3, red, as they go along the top. It's a bit of a meditation. After we've done our 1s, we're going to do our 2s, and I ask the children what colour we need. In other words, to make sure they understand that all the 2s are even, because 2 is an even. It becomes apparent through this process that any multiple of an even must be even. All these subtle learnings come in. So then they do the 2s. So a 2 is 2 1s. So we see odd 1, even 2. If the children don't understand that, use your pebbles. 2 1s makes a 2. So every 2 needs 2 1s. So we can see 1 1, 2 1s, 1 2. Another 2 1s, another 2. Another 2 1s, another 2. And then the children do their 2s all the way to 100. So by now they're getting into the rhythm of it and seeing that every second one is a 2. So we're building relationships between the numbers. We're already seeing a subtle relationship between 1 and 2. Now the next number we go to is even 4. Why do we go to even 4? Because it's the next member of the family. Even 2, even 4, even 8. So here I've drawn the beginning. So I've done the odd 1s, even 2s, and I write in the numbers there, but we go to even 4. So 2 2s make a 4. So the children could go 1 lot of 2, 2 lots of 2 makes 1 lot of 4. Another 2 lots of 2 makes another lot of 4. Another 2 lots of 2, and I call this pulling out the 4s. So we don't need to know our 4 times table. What we're doing is connecting to the fact that 1 4 is 2 2s, and that goes ad infinitum. So all they need to do is pull out the 4s, and then they've got their 4s all the way to 100. So we can see now 1 lot of 4, 2 lots of 4, 3 lots of 4. So don't rush this, keep relating the numbers back, is how many 2s? Well, 1 lot of 2, 2, 3, 4, 5, 6. 6 2s is 3 4s. That's lovely. if they're not catching on, what did we say? 6 twos, 1 lot of 2, 2 lots of 2, 3 lots of 2, 4 lots of 2, 5 lots of 2, 6 lots of 2. How many 4s? Let the children do it. 1 lot of 4, 2 lots of 4, 3 lots of 4. So we're connecting again the 2s and the 4s. Lovely. From the even 4, the next family member is even 8. So now we go to our even 8. So 2 4s makes 1 8. 2 4s makes 1 8. Another 2 4s makes another 8. So the children now pull out the 8s. I call it pulling them out. They don't have to know their 8 times table. All they need to understand is that 2 4s make an 8, and they've done their 4s all the way to 100, so now they pull them out. 2 4s makes an 8. Another 2 4s makes another 8. Another 2 4s makes another 8. So we can see that 3 8s, 1 lot of 8, 2 lots of 8, 3 lots of 8, is the same as how many 4s? 1, 2, 3, 4, 5, 6 4s is the same number as 3 8s. This is really important. Connecting the numbers, the relationships. So once we've done even 2, even 4, even 8, all the way, and we can practice multiplying and dividing by those numbers. So if I say 24 divided by 8, where does the child go? What am I asking for? I've got 2 10s and a 4 to share with 8 children. I'm looking for 8s in that 2 10s and a 4. So I'm looking for 8s in my 2 10s and a 4. 1, 2, 3. 24 divided by 8. 1, 2, 3. 25 divided by 8. 1, 2, 3. And 1 remainder. So we've got all our remainders here as well. So we can multiply and divide all these numbers just by looking at our charts. So the next number we go to is even 10. Even 10's relatively easy for everybody by now, I hope. So we do our 10s, 1 lot of 10, 2 lots of 10, 3 lots of 10, 4 lots of 10, all the way to 100. Always ask the children, what colour do we need? Just to make sure that they understand, because 10 is an even number, all the multiples of 10 are going to be even. Yes. And now, who's 10 related to? Who's even 10 related to? He's related to odd 5. So we can see that 2 odd 5s live within an even 10. So now we can work back to our odd 5s. What colours are we going to need? Odd 5 is an odd number, so we're going to need our red and our blue, because every odd number alternates, as we've seen with our stamp clap speak for odd 3. If the children aren't sure, ask them to hop up and do stamp clap speak for odd 5. Odd 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're alternating. So we need our red and our blue pencils to do our odd 5s. Here's our odd 5. First, 1 lot of 5 is an odd 5. 2 lots of 5 is an even 10. 3 lots of 5, we get an odd again. 4 lots of 5, an even 2 10s. So we do our 5s, easy peasy. By this stage they're falling into a bit like a meditation. It's lovely. What do I do next? Okay, we can choose what to do next. We might do odd 3. If we're not sure of odd 3, first of all, what colour? I need a red and a blue. 3 is an odd number. We alternate. When we add an odd, we change. Add an odd, change. So we can do our stamp clap speak first to make sure we've got the rhythm of the 3s before we start writing. So we start odd 3, even 6, odd 9, even 12, all the way to 100. So now we work with the family of 3, 6, 12, which is similar to the family 2, 4, 8, in that it is double, double. So once we've finished our threes, our odd threes, we can have a look at it. I say to the children, who's next? I always ask them the questions. I try to not teach. I try to elicit the answer or the process from the child. Well, they enjoy it and they feel good because they know, and that's a way for me to make sure that they know what they're doing or that they understand what's happening. So we've got even 6. So we've got 2 lots of 3. We can see with our even 6, 2 lots of 3 makes an even 6. What colour do we need? We need blue because 6 is an even number. So we can see we're going to leave out the odd numbers in the 3s. We're pulling out the even 6s. 1 lot of 3, 2 lots of 3, 1 lot of 6. Another 2 lots of 3, another lot of 6. 2 lots of 6 is 4 lots of 3. Wonderful. So we pull out our 6s all the way to 100. And the children by now are feeling very successful with their multiples. They're feeling very confident with their multiples, which is wonderful. So the next family member after even 6, of course, is even 12. 2 6s makes a 10 and a 2, makes a 12. 2 6s makes a 12. Another 2 6s makes another 12. So we do our 12s. So now we've done 1s, 2s, 3s, 4s, 5s, 6, 8, 10 and 12 times tables, which is pretty amazing without learning any times tables. Lovely. Now we can do our 9s. Now we've got numerous ways of doing our 9s. We can either do 3 3s makes a 9, another 3 3s makes another 9, another 3 3s makes another 9, or we can use the way that we've learned or understood that a 9 is a 10 minus 1. 1 lot of 9 is a 10 minus 1, odd 9. 2 lots of 9 is 2 10s minus 2, a 10 and an 8. 3 lots of 9, 3 10s minus 3. So we've got 2 different ways, we've got more ways than that, of doing our 9s. And we know we need our red and our blue because 9 is an odd number. So we can do our 9s. What have we got left? We've got 7s and 11s left. So we look at our odd 11, which is a 10 and a 1. 1 11 is a 10 and a 1. 2 11s are 2 10s and a 2. 3 11s, 3 10s and a 3. And 11 is what sort of a number? It's an odd number. What colours do we need? We need our red and our blue. We're going to alternate. So 1 lot of odd 11 is odd 11, even for 2 lots of 11, odd for 3 lots of 11. And away we go up to 100. And now we're left with poor old lonely odd 7, who doesn't seem to have a lot of family here on this page, which I find quite sad, but 7 likes to be alone. That's the nature of odd 7. We've all got a bit of odd 7 in us sometimes, don't we? We just like to be alone. So with the 7s, we can turn them around. If we don't know what 2 lots of 7 is, we can see what's 7 lots of 2. And that comes from the grid building that we did formerly, where we build 7 lots of 2. Look at it the other way, it's 2 lots of 7. So if you're not sure what that's all about, please go back to the video on grid building to see that any multiple can be turned around. The only number we need to remember is 7 lots of 7 which is 49. So for all the multiples up to 12, 12 times, which is what we're required to learn at school, the only one that we need to hold in our head, or we can work it out from the one before or the one after, is 7 times 7. I can remember that. 7 times 7 is 49. And the rest we see on our chart. So that takes care of all the multiples. Now, there's more to this chart than just being able to multiply and divide, including remainders. So if I say 22 divided by 9, I come to 22 on the 9 row. I see 1 lot of 9, 2 lots of 9, and 4 remainder. So that's how we divide by anything using our chart, including remainder. Later on we'll see how to make those into fractions or decimal remainders, but right now we're just doing remainders. All right, so now that we've completed our chart, and I'd let the children have a rest after they've completed their chart, the next task is to look for what I call popular numbers. Now, what do I mean by popular numbers? So when we look along here, some numbers are very full. They have a lot of multiples in their column, like even 24. The first obvious one, and I would start with smaller ones with the younger children, let them pick out a popular number. So they might pick out even 12. So who lives in even 12? Well, odd 1 lives in everybody. Even 2 lives in even 12. Odd 3, even 4, even 6, and of course, even 12. So these are called the factors of 12. So here, instead of teaching factors as an intellectual construct, we're actually seeing what it means. So even 2 is a factor of even 12, and we look at how many 2's make the 12, so that we see 2, 6. Odd 3, how many 3's make the 12? 4, 3, 4. 3 times 4 is the 12. 4 times 3 is the 12. 2 times 6 is the 12. And these are the factor pairs for even 12. So I think this is a very nice, benign way to understand factors. So the children will, if they're given the time, they'll start looking at the factors of other popular numbers. You don't have to call them, I call them popular numbers because a lot of people are interested in them. So after we've looked at our popular numbers and done a little bit of work on factors, we then look at the opposite. We look at the unpopular numbers. Oh, let's look at the unpopular numbers. Ask the children, can you see any numbers there that are unpopular? We can see odd 7, odd 11, odd 13. Is it every odd number? There's odd 15. No, he's not unpopular. No, it's only some of the odd numbers. So they're actually exploring the odd numbers to 100. So when I went to school, we had to know the prime numbers to 100, which were pretty impossible to remember for most children. I mean, I can't remember things that are not connected to something. So here, the children, and I explained to them these are called prime numbers, can pull out the prime numbers. They're obvious by the fact that they have nobody in their column. So that's very interesting. And it makes it easy for them to see what a prime is. You don't have to explain it. They see it for themselves, what a prime number is. And I suggest that the children familiarise themselves with their primes. This will be very useful. For example, when we start simplifying fractions, it's good to be aware which numbers are prime. If we've got 7 over 11, 7 elevenths, and the children know that both those numbers are prime, it's obvious they can't simplify. So now we've not only got our multiply and divide, we've got our factors and we've got our primes. Well, that's not all we've got here. We've also got our lowest common denominators and our highest common factors. So when we come to fractions, I like the children to do this chart before we ever start on fractions, because this makes fractions easy. So when we come to adding a half and a third, for example, we put our finger on even 2 and a finger on odd 3, and we roll along till we find the first number they share, which is even 6. Even 6 is the lowest common denominator of 2 and 3. We don't multiply 2 by 3, we look, because if we have a quarter and an eighth, we don't multiply the 4 by the 8, we go on the 4 and the 8, and the first number they share is even 8. Even 8 is the lowest common multiple of 4 and 8. So the children can find their lowest common multiples by running along and seeing them. And I think this is quite fascinating. I love this chart. It's fascinating. If it's on the wall, it draws your eye. You can't help but looking at it and seeing more things here, more connections. For example, we can see our squares and our square roots, which is lovely. We can see more than that. The children, let them discover. This is a treasure trove of number connection. So we're not learning 2 times tables, 3 times tables, 4 times tables, where they have no relationship to each other. Every number here is connected to all the other numbers, and that's the reality of our number world, and that's what makes it beautiful, and this is what makes it easy.